Okay, we're good to go, and welcome to this first Google Hangout about the upcoming Pluto New Horizons encounter. And the reason we're doing that here at the National Astronomy Meeting in Llandudno is because we have two specialists here who are quite happy to talk about it. I should, of course, say who I am. I'm Rob Massey. I'm the Deputy Director of the Royal Astronomical Society, and we're running the press room here this week. So we're going to give everybody a chance to ask questions via Twitter and hopefully via the system here as well. My colleague elsewhere in the room will be handling that. But I'll introduce our guests here today. Okay, this is Dr. John Marchant of Liverpool John Moores University, and he's going to be using a telescope to study Pluto during the encounter, telescope here on Earth. And this is Dr. Jane Greaves, who's a reader at the University of St Andrews, and she's actually had a history of doing various studies of Pluto on the Earth as well. So that's why I think they're great guests to speculate about what New Horizons is going to see. That's something I think that very many people are very excited about. So, John, perhaps if you want to start by telling us about your work.
Yeah, well, basically what we're going to be doing next week is just using a spectrograph to, well, basically a spectrograph is the thing which takes the light from Pluto and effectively sort of passes it through something like a prism. Yeah, it's actually a different kind of device, but it acts the same way, but a lot better. And it splits the light up into all its component colors. And different elements, different chemicals fluoresce or give off light or reflect light in very specific colors. And so if you plot a graph of the brightness across all the different wavelengths, you can pick out the molecules in your image, and that actually shows you, well, for a start, if the chemicals are there, and also by the height of the spike in the graph, how much of the chemical is there as well. So really, the people involved in the ground-based part of looking at Pluto during the flyby, they want us to do long-term monitoring of the variation in the spectrum of Pluto, both during the flyby and for weeks and months afterwards as well.
Okay, so that's really so that you can do the work here on Earth to compare your results with what the spacecraft's seeing.
Yeah.
Presumably we'll be doing this kind of thing, but in much more detail.
Yeah, it's called, it's in the terminology of remote sensing. It's basically like getting ground truth. Until now, human beings have only been able to use telescopes to look at a very distant fuzzy blob of Pluto. This is the first time, and maybe the only time for a very long time, that we're going to have some close-up pictures. So what you want to do is take images from Earth again during the flybys. So from then on, you can match up what's actually happening with what you see on the telescope.
Can you remind us how far away Pluto is right now?
Right now, it's about 40. It's just over 40 astronomical units away from
5 billion kilometers. So that's in order, isn't it?
That's
6 billion.
That's something like that. Yeah, it's a very long way away.
And light takes how long to reach the Earth? And the radio signal's traveling at the same speed.
Yeah.
So slow back. Yeah. So there's nothing you can do.
No, I'm afraid not. You just basically got to sit and watch. And they actually had problems like that. Just digress slightly with Apollo. One of the astronauts actually caught his foot on a cable to one of the instruments, which they just placed on the surface. And they could see in the couple of seconds that he was going to trip over the thing and pull the cable out. And there's nothing they could do. They just had to watch him trip over the cable out. So.
And I imagine there was some colourful responses to that.
Yes, it was probably
lost. Exactly. Yeah,
probably bleaked out. Yeah.
So, Jane, do you want to tell us what you've been doing? What work you've been doing on Pluto, and perhaps anything you've got coming up as well?
Sure, it's also part of this sort of ground truth, because we know Pluto changes over the years, surprisingly rapidly as ice boils away from the surface. So a lot of what I do is actually more like radio wavelengths, light waves about 1 millimeter long. And we've done some recently also with the European Space Agency's Herschel spacecraft, which is the far infrared. But all these longer waves are telling you things that are not obvious at all to your naked eye, and to some of the instruments on New Horizons. So you look, for example, at gases in the atmosphere through the distinctive sort of spectral fingerprint, and that tells you a lot about what's there. Methane, carbon monoxide, things that would be really unpleasant in the atmosphere of the Earth, but are really vital to Pluto having an atmosphere at all.
And that's because it's so much colder that these, presumably, a lot of the stuff freeze out, otherwise they wouldn't be
Yes, I mean it's ice on the surface where it isn't bare rock, and this stuff just basically vaporizes because it's much too cold to have a liquid, and there's no pressure to hold a liquid there anyway. So you've got this very odd atmosphere that comes up from the ground, these ice patches, and those can change. So the advantage of using these radio wavelengths is some of those particles of light actually come out from below the ground, below where we can see John's optical light observations.
There are suggestions, wacky suggestions about Pluto's subsurface up there, like something suggesting there's liquid or something.
Yes.
Kind of thing. I don't, you know, it seems hard to believe it's something that small, but you know, I don't know if you want to comment on those and whether they're realistic or we should discount them.
I think it's not impossible. It depends how much radioactive material was incorporated when Pluto was formed by smashing rocks together. If it was an unusually large amount of that, the radioactive decay can be a sort of internal power source.
I wouldn't like to guess. I mean, in the history of space flight throughout the solar system, people have had theories on what they might see there. They've been proven wrong more often than they have been proved right. So it's anyone's guess, really.
Yes, I think New Horizons pictures are showing us that already. We didn't go, oh, there's a big square bit and full circles.
Well,
we didn't order that.
Exactly. And, and you were quoted in the Sunday Times as talking about having red and blue, red and yellow areas. And so, I mean, presumably that's all relative. You're not necessarily talking about scarlet and brilliant yellow, or are you?
Well, the pictures are coming back. Yeah, you might say it's a sort of a storm-coloured brown, but I think as we get closer, we'll be able to really see different coloured areas. Yeah.
And the light levels must be, I mean, it's a long way from the sun, so the light levels must be pretty low. I mean, I guess the sun, as I understand, would still be a lot brighter than any star, far brighter, much brighter than the moon, for example. But the moon is something on Earth. But yeah, I guess I'm just wondering, you know, that okay, you've got a very advanced camera, but you know, presumably a lot of you were actually there and you're looking at it with your eyes, you can see everything would be a bit more subdued.
I need to take a torch, I think.
Yeah. Well, actually, I mean,
the future astronauts.
If you actually were there, though, I mean, the light levels are, I can't remember the exact figure now, but the light levels on Pluto are about what you get on Earth, something like about perhaps like 10-20 minutes after sunset.
Yeah,
and it's actually about a 1600th of noon light levels, and that sounds like a tiny amount, but your eyes actually adapt. So if you actually were standing on Pluto, you probably would be able to see well enough to move around without tripping over anything.
Well, parts of it are very shiny and white as well.
Well, yeah, that helps.
Yeah, you know. So you'd be able to see as you slid over on the ice.
It'd probably look like a snowy landscape under moonlight on Earth.
Yeah.
Sort of.
So not as bad as people imagine.
No, you wouldn't be blind, blindly stumbling around or anything.
Okay. So I guess you know, all this will be over in a few hours, and that's when it gets its closer picture. Is there anything that you would like to speculate about what we might find? Not wishing to put your careers on the line.
I think I don't know. It's something that would in the long run would be able to advance our knowledge of what the Kuiper belt is actually like. Which is
you want to tell people what the Kuiper belt
sorry,
is?
The Kuiper belt. The Kuiper belt is a belt of very primordial objects that are orbiting the solar system outside the orbit of Neptune. And Pluto, we now realise, is just one of probably the largest body in that group of objects. So it's not a standalone thing; it's just one of many. So really, the New Horizons mission isn't really a mission to Pluto; it's a mission to the Kuiper belt. And Pluto is like one of the best examples. Well, a good first start at looking to see what the Kuiper belt is. And the Kuiper belt is objects that were around when the solar system was formed. So they're sort of like flies trapped in amber. By analysing them, we can find out exactly what the solar system was like 4.5 billion years ago. So,
any thoughts?
I think I'm particularly interested in the atmosphere because we don't really completely understand how climate works on Earth and things like long-term changes to the atmosphere. Even if, you know, one of those giant meteorites that came over Russia came through, we don't know what that does to the atmosphere. And Pluto's, which is in a way cold, thin and simple, enables us to just look at whether our basic equations of physics are right for atmospheres. So it's been suggested some quite peculiar things, like the atmosphere might actually snow out as nitrogen snowflakes to the ground before the spacecraft got there, which would be a bit disappointing. And everybody's saying like, no, we didn't quite have the physical constants right for nitrogen. So fortunately, that hasn't happened. But
can I ask another question for both of you? Do you think it should still be a planet, or should it have been downgraded to a dwarf
well, we
planet?
never saw that one coming.
No.
The mission launched. I remember sitting in a studio in 2006. Mission launches. 6 months later, they're no longer sending a space probe to a planet. You know,
I doubt Pluto cares really.
I imagine.
It probably can't speak English anyway, so you know. I'm totally unconcerned about what category it is. It's still a fascinating object in its own right. I'm not bothered myself.
I'm not bothered. I think dwarf planets are a really interesting class of object. They're mysterious, they're very diverse, very different to each other. It's really a descriptive name. It was never meant to be insulting, I think. and their worlds, that's what the thing is. It's a round ball with features, geography, all these things happening. It's a world. It's maybe a better name.
It's a real object. It's really there. It's a real object.
We're just starting to realise that.
It's as real as Llandudno.
Say, I mean, you know, in the last few weeks, this is the time. You know, all the pictures we've had in the last few weeks, even though the spacecraft is still quite a few million kilometers away, are utterly unlike anything we've seen before. Because even Hubble gets, you just about see the dark and light features. And make hopeless maps, and suddenly.
This is the weird thing. This kind of thing hasn't happened since the Voyager flyby of Neptune. You know, this is the first time human beings in the history of the universe have seen Pluto close up ever. You know, this is a privileged moment, folks. You know, sort of make most of it.
I mean, it's almost as close a view as the Huygens lander got on the Titan. So, you know, we're not quite going down into the landscape, at least I hope not, but it's going to be amazing detail. Almost like being on the world.
Should we see if anybody wants to put any questions? I don't know whether they'll do it via this chat thing. If you're logged into this and you know what you're doing, which we don't necessarily, then please try and put questions that way. You can also tweet them. My colleague Sam at the back is checking questions via the hashtag NAM2015. So just a reminder, if you just joined us, this is a hub. Calling a Hubble Hangout, so a Google Hangout about Pluto and what we might expect to see from the New Horizons mission next week. And I'm here with me at the National Astronomy Meeting are two UK experts on this: John Marchant from John Moores and Jane Greaves from St Andrews, soon to be in Cardiff as well. So, any questions? Fire away. I don't know, Sam in the background. Anybody coming up with anything? No, he's shaking his head. Well, guys, you know, now is the time. NAM 2015 hashtag. I can see there's a few people watching this, so.
People geographically here are eating lunch before it
disappears. That's true. Yes, that's certainly people in the room. Yeah, exactly. Yeah, we're not really bothered about people at this conference can come and find these two, frankly. So we don't care quite as much about that. But we'd be very interested to know if anybody's got any questions about this mission. I know there were a couple of journalists, for example, who were interested. So I mean, obviously you can put those questions directly to me by email and so on. Just looking at the hashtag to see. This is the disadvantage of doing it on the plane, but okay, well maybe, I mean, look, we've got a bit longer in this, so I guess I was just thinking about the way in which this thing's worked. I mean, it's been traveling for 9 years, and can you remind us if it went?
No, it's it needed to fly by Jupiter to get a huge gravitational boost. It couldn't have got to Jupiter to Pluto without going to Jupiter first. So it actually did. They switched on the cameras when they went past and looked at Jupiter's cloud levels, and I think they did some of the moons as well, did they?
Yeah.
So that was of necessity. They had to go through Jupiter, but they also just trying to remember if they actually looked at some asteroids as well.
Well, one of the interesting things to me is there's an instrument on New Horizons that was actually built by undergraduate students, and it's kind of mapping out the particles in the solar system. So that's the instrument that's been turned on the whole way, unlike the cameras and so on. And it's just collecting little sort of pings of dust as it goes out through the solar system. And this has never been done before, just counting how much stuff there is in the solar system. And these are sort of tiny, tiny, tiny meteorites, but, you know, smaller than the width of a human hair, that sort of size. Otherwise, the speed the spacecraft is moving, that would be a pretty nasty encounter. But it tells us how stuff crashes together in the solar system and where asteroids have been and stuff like that.
Because there was a worry, wasn't there, that the mission might encounter debris around Pluto.
Yes.
And it seems to be talked about rather less now. Perhaps you can tell us something about that as well.
I am not sure why it's being talked about less now, but I still think there's a risk myself. I mean, they only expected to have Pluto and Charon, its largest moon, in its orbital plane like that, but then they found 4 more moons. So
yes, that was after launch.
Yeah, exactly. Yeah. So I think they actually had to sort of slightly tweak the trajectory very slightly, just to put it into like just to be absolutely sure, as near as damn it, that they've gone through the place least likely to have anything in it, but they can't be sure. And at that speed, it's like 14 kilometers a second. Something that big will just blow it to pieces.
Do you think so? Is the idea there's a debris ring or something like it?
That was one of the ideas put forward, because we know all these little systems of mini worlds and mini moons out there do produce particles coming off in collisions. The most recent work I've seen, I think why there's less concern now, says that the system is pretty packed with the moons, although they're not very big. Their orbits are reasonably close to each other, kind of in the way we see for Jupiter or Saturn. That was lined up, and the hope is that you can't fit much more in there, because it would just be thrown out. It'd have its own like little gravity boost from a moon. So yeah, I don't think we can say about things, understanding Saturn's rings, for example, is really hard, even though we've known about them for about 4 centuries. But yeah, I think there'll be some excitement, but we don't really want to see a mini moon we didn't know about and a really close up.
That would be less. I know. I feel for mission scientists. 9 years after launch, after travelling all the way there, the last image they get is one hopes that doesn't happen. There's no sign of any additional moons yet, are there?
Not that I've heard of.
No, I mean the ones that are being imaged at the Hubble and from the ground, and also as New Horizons approaches, are pretty small. I mean they're a rock a few kilometres across,
so we can
but they're not
probably
massive.
so we can be confident they're probably bigger than that. The risk is you find, well, apart from as you're saying, even a small particle does a lot of damage. You worry about pebble-sized things.
We're 5 days away now with a 9-hour communication lag, so you can't really do anything now. I think all the stage is set.
I'm afraid not. No, it's
exciting.
Just hope that the mission doesn't end with just like a spectroscopic result of like a strangely glowing cloud of titanium and aluminium or something like that.
We certainly don't want that. That'll be an anomaly. No, quite. Well, I mean, I think it's quite evocative. That's why I was saying this is the last, when it was launched, the last planet that we hadn't sent anything to, for obvious reasons. It just took so long to get there. I mean, and as far as I know, is it fair to say there's no plans for any other missions, or not even? I mean, I guess people always come up with proposals, but.
Well, there's an extension to the New Horizons mission that they can use a bit of gravity from Pluto to slightly redirect the craft, and hopefully visit another object in the Kuiper belt. I think that object has been, so I don't know its name.
I think it was P2, wasn't it? No, it was, they had a short list of objects which they hadn't given actual names to, and then they said, "Oh, let's go for that one. That's the best."
Possibility number 2.
Yeah, I think they have actually named it now, but I can't remember it now. But yeah, so it just requires a very slight nudge. I can't remember how long it's going to take to get to that one.
Yeah, I don't know. Get there. And that's
going to tell us something else as well. I mean, on the one hand, you sort of say, Pluto is a good example of the Kuiper belt, and fair enough, that will tell us a lot. But if you can, then don't just stick with one measurement. Make a few at least, So because who knows? I mean, if the next Kuiper belt object you look at looks exactly like Pluto as well, or looks completely different, that's going to take your reasoning one direction or the other.
I mean, there's already clues, because they found during the mission that the moon Kerberos is really dark, and if the whole system formed for some kind of giant impact, maybe this is a part of the core material of one of the 2 bodies. The little dot bit got knocked down. So I don't think you'd find another exactly the same system, but it would tell you a lot. How is it different?
It could be that this is like the beginning of discovery of a completely astonishing part of the solar system we were completely previously unaware of.
Yep.
So
this is a lot of the place where comets come from, and we're familiar with the idea of those coming near the Earth and pressing people.
There is the connection with the RAS actually, it's a very tenuous one, which is that when it was named by Venetia Burney, who actually only recently died, it wasn't that long ago, a few years ago, she she submitted the idea for Pluto via her dad in Oxford. And then the Americans, I guess I'm not quite sure what the naming process was, but it was her suggestion.
Sponsored this,
well,
9 or 8-year-old girls.
Well,
exactly,
I think that's great.
And the year before she died, I went with her to St Sussex, and she saw Pluto. But I hadn't realised through telescope.
really?
Yeah, it was 89, and she said, and she was very fair in there's a film naming Pluto, you can look up, that describes it, and her reaction was, well, it's not much to look at. That was very fair, I think. For
Yeah.
I mean, I've never seen it through a telescope either at that point, and I just this dot. We had a very talented amateur astronomer to point the telescope in the right place.
The three of us, you'll be the one who actually be able to tell what it looks like.
I was going to say, exactly.
Well, yeah, this looks like a dot, really.
Yeah.
But, I think I've worked out, actually, it's about as bright as 600.
Something to think about, isn't it? Really? That shows you.
Pale yellow dot, isn't it?
It's a very, very dim dot. For any astronomers out there, you need a telescope at least this wide to see it properly. So,
I know a lot of amateurs are giving it a go.
Are they doing things during mission?
Yeah, for us in Britain here, unfortunately, it's not very well placed. It's very, very far south, but there are many places with good dark skies in the world.
So what are they hoping to do? The same sort of stuff John is doing, or on a smaller scale? I don't know.
I don't know what the amateurs are hoping to do.
I think there's a lot of seeing how the light looks like from the Earth, because this is how we've had all our information as it turns, as we see it from the Earth, about every 6.5 days. You've got a total light signal, and I think making sure how that fits in, like you were saying, because Pluto really, New Horizons only gets close-up photos of one side of Pluto because it's going through so fast, although we're seeing as it approaches various sides. But putting that picture together, the whole light of objects you see close up is often a very difficult problem in astronomy.
So, yeah, I just think it's interesting though that it's been known for years now that Pluto's brightness varies quite a lot over its 6.4 day period, and there's been some very sort of value from the light curves. You can just take the images and see there the light changes and infer what must be on the surface so that you see that. And now we're getting these close-up photos, and it's like, well, we sort of knew it was blobby and patchy anyway, but it's just so nice to actually see the blobs and patches close up.
I'm sure there's a lot of people out there who've done this work going, was I right? Was I right? My St Andrews colleague, Professor Keith Horn, did some work on this in the 1980s and made some beautiful computer reconstructions of the dark belt at the equator. And we've actually seen this this morning, the first camera images that came back after the brief time out.
Let's see whether anybody's been asking any questions. This is right. We've just had the best question ever online. Somebody has asked Jane here whether she has plans to update her crocheted model of Pluto. I don't think John's able to answer this one.
No, I didn't know you made one.
A big theme of the meeting here is outreach and getting people involved in astronomy. And sometimes astronomers themselves are not very good at thinking in new ways. So, because I'm a crafter, I came up with this idea of get a Chinese lantern and cover it with little crafted bits that look like the features on Pluto as they've been discovered. So it's supposed to be sort of crowdsourced and interactive. We've had it around for about 4 days now. At least one brave person has added a new knitted feature to model Pluto. Into the area, too scared to mess with it. So I'm hoping other people.
Do you think people worry about their professional reputation if they add a feature?
Well, we're doing it from the pictures.
Well, that's pretty fair.
That's fair.
So people demand this we saw.
They should be. I knitted the first half of that when we saw half of it a couple of days ago.
So you need to add
now we need to add the other side, the mauve and the heart. But
I think whoever brings out the first proper globe of Pluto with all the things. I'd like one of those.
I think 3D printing as well. I hope they'll make it available, and then you can go to your local 3D printing shop or your university, or if you're a hobbyist and you've got your own, then get an actual model of the
that would be great, wouldn't it? Actually, if there are a few of these.
I mean, a lot of universities have done this with the comet, that the Rosetta mission.
Oh yeah, I've seen one of those.
It's actually really helpful from a professional viewpoint. You can go.
I remember
handle it and think about how it came to be.
Years ago, when I was in Greenwich, we had a lumpy moon, so a tactile moon, fantastic. Actually, to get more of these things would be great. actually. I mean, this wasn't 3D. This was long before 3D printers.
Right.
So,
Yeah.
but it's a fantastic.
But 3D printers are becoming a great tool, particularly for blind people, and it's moved on from like braille constellations to actually being able to handle things. And you know, I just want everybody to be able to be involved in astronomy and not think, oh, it's not for me, or it makes me feel stupid or something. I mean, it's very visual and tactile subject.
Yeah, I was wondering, would there be any mileage in using a 3D printer to print out a FITS file image, like where brightness is height? So you know,
Exactly.
so it's like it's basically
So
a 2D photo.
or something,
Yeah.
spikes.
And then you could feel where the things are, and you feel the shape of the galaxy and things like that.
I'm sure the people out there know how to do this.
I'm sure somebody's printing one out right
I
now.
think
So,
so.
yeah.
Yeah,
But you
that's right.
can
Just
take
send
image
us your,
formats and turn them into computer-aided
Okay.
design software formats, and that just works. And then you can print something that you have. And I think
Let's see if anybody else has got anything else. No, Sam shaking his head. Okay, well, we don't have so many people watching, but I've got one question to finish up with, I think, which is, do you think people will ever visit Pluto?
Oh, ever? Yeah, definitely. I mean, it depends on your time scale. In the next 5 minutes, probably not, but in the next 500 years, I would have thought so. You know.
Yeah, I mean, some amazing technological advances going on. Things like solar sails. I mean, this may not be so relevant to the solar system, but it's kind of the technology to use the light pressure of light coming out from the sun on a sort of shiny piece of bin bag to ultimately send a spacecraft to another star system. But if those could travel at a tenth of the speed of light, instead of it taking 9 years to get there, it takes just 10 times longer than the light's coming back. So instead of 4.5 hours, that's 45 hours. I mean, that would make a nice vacation, wouldn't it?
2 days, yeah.
Yeah. Weekend trip to Pluto, anyone?
Yeah, we go to
Well, I was going to say that's the point at which you start to imagine serious exploration, because when you talk about tens of years to get somewhere, or even 2 years,
and then you can't stop. It's like, are we there yet? We were.
Yeah. We were. Breaks not
we didn't
working.
stop for a loo break. Yeah.
Into the abyss. It's not a good thing.
But no, I mean, it's just down to how long it takes to get anywhere. I mean, you know, now that we can travel to the other side of the planet in, again, about like a day and a half or something, then it's suddenly it's feasible to do that. So, you know, maybe 50, 100 years time, if there's some big breakthrough in spacecraft propulsion technology, you'd have holidays in.
I mean, exploration tends to have practical purposes, like opening up the American West. There may be rare minerals, the kind of stuff that's rare on Earth, but we now need to go into our cars, for example. There's some very rare metals. Because if we found those on an asteroid or on
the economics of that are very complex, aren't they? I mean,
right now it's too expensive as well. But I mean, if you keep going on, if you keep pushing the boundaries of technology and everything, then it suddenly becomes economically viable. You know. And besides, I mean, you need to just do some terrible phrase, but blue sky thinking. You just need to see you just need to explore and see what's out there sometimes, because you just don't know what you're going to find. I mean, you might find something really useful.
I mean, I suppose if you want a crazy hypothesis, then you have some space elevator on Earth to get you to orbit, because that must be the biggest problem as well.
Getting out of the gravity well.
The gravity well of the Earth is hard, and then you have your sails or some advanced propulsion system to take you around.
So you take the lift of the boat and then
exactly
up anchor and sail away.
The cruise terminal in orbit.
I can't wait.
I was going to say we would all look forward to that, wouldn't we?
I think we would.
Right, I think we're coming to an end unless there are any further questions or something. No, shaking his head there. Well, anyway, if you have been listening to this, then thank you very much. And
we'll see you on YouTube.
Exactly. And we'll see. And if you do want to ask them any questions via Twitter and so on, I'm sure I can put them to them as well. So, other than that, thank you very much. This is us signing off from the National Astronomy Meeting in Llandudno, North Wales. And now that this is over, we can open up the glorious sunshine into our impromptu studio again. So, thank you very much. Bye now.